Hi everyone, welcome back. We're still looking at our standard 6.ee.a3, apply the properties of operations to generate equivalent expressions. Today we're going to look at a few more complex order of operations expressions and then some word problems. So just a quick review, we are using GEMDAS, which stands for grouping symbols first, then exponents, multiply and divide from left to right, add and subtract from left to right. And then here are a few examples of our grouping symbols, right? It's not just limited to parentheses, and that's the reason why we're using GEMDAS, because we have brackets, braces, absolute value bars, radical sign, and fraction line. All right, so here are some examples. Let's go ahead and take a look at these. So we're using our GEMDAS. So we know grouping symbol first. So inside the grouping symbol, we have 8 minus 5, which is 3. And now that's being raised to the third power. So I'm going to bring everything else down. Okay. Now GEMDAS tells me exponents should be next. So 3 to the third power. So 3 times 3 is 9. 9 times 3 is 27. Okay, so this is 3 times 3 times 3. We did this in our exponents unit. And I'm just going to keep bringing everything down because it just really helps to keep my work organized. Now I have multiplication and division. So I'm going to multiply and divide from left to right. So I have 27 times 3 minus 8 divided by 2. So 3 times 7 is 21. 3 times 2 is 6. Plus 2 is 81. So 27 times 3 is 81. And then I'm bringing everything else down. Now I'm going to divide. So 8 divided by 2 is 4. And I'm bringing down my 81. And now I'm subtracting. So 81 minus 4 is 77. Okay? And that's what should have been your final answer here. Now let's move over to the next problem. So still following our GEMDAS, we want to start off with our grouping symbol, which is 2 plus 5 is 7. And I'm going to rewrite the rest of it. So I'm going to change up my colors here just so we can see where I'm working on in each step. So we completed our grouping symbol. Now let's take a look. What's next? Exponents. So I have an exponent here. 2 to the second power is 4. And I'm going to bring everything else down. Okay. Now I know that GEMDAS tells me that multiplication and division are on the same level from left to right. And this is an area that a lot of people do get confused. So you might be tempted to say 4 times 3 first, but we really need to divide 16 divided by 4 because the reading from left to right, the division is happening before the multiplication. So 16 divided by 4 is 4. And then I'm going to bring everything else down. Times 3 minus 7. Now I can go ahead and do my multiplication. 4 times 3 is 12. Minus 7. 12 minus 7 for a final answer of 5. Now let's take a look at the third example. So here I have a fraction bar, and the fraction bar represents a grouping symbol. So what that means is I need to complete everything on the top and then everything on the bottom. And we know the fraction bar is also a representation of division. So everything on top will be completed, everything on the bottom will be completed, and then I can divide. So let's go ahead and take a look at that. So on top, we have exponents, but we also have a grouping symbol. So I'm going to go into the grouping symbol first. Now, when I go inside my grouping symbol, I see an exponent. So that means I'm going to need to evaluate the exponent before I can wrap up my grouping symbol. So 2 to the third power is 2 times 2 times 2, which is 8. And then I want to bring everything else down. So I'm going to keep that parentheses plus 4, and then times 3 squared all over 2 to the second power. Now I still have my grouping symbol, so I want to finish that up. So 8 plus 4 is 12, okay? Now, I can choose to rewrite the parentheses if I want to, but I know that the parentheses is the same thing as multiplication. So I'm just going to bring down my multiplication sign and then my 3 squared. Okay, and that's all over 2 to the second power. Now, again, I'm still finishing up what's on top. So 3 to the second power is 3 times 3, which is 9. Okay, and then I have my times 12, and that's all over 2 to the second power. Now 9 times 12, so 9 times 2 is 18. Carry the 1. 9 times 1 is 1, plus 1 is 10. So 9 times 12 is 108. And now I can evaluate the bottom portion of my problem. So I'm going to rewrite it first. So 2 squared. Okay. And then now I can evaluate that 2 squared is equal to 4. So I have 108 divided by 4. And my space, as you see, I've kind of run out of space a little bit, but we're going to finish this up anyway. So now I don't want to leave it this way because that can be simplified. So 108 divided by 4, now what is that equal to? So 108 divided by 4 is equal to 27. And that would be your final answer. So this expression, when simplified, is equal to 27. So now let's take a look at our word problems. Johnny sold 12 comic books and MJ sold 9 comic books. They sold them for $5 each. They want to know how much their books are worth combined. So pretty much they're asking how much, right, did they sell in total. Now we're being told to use the distributive property and order of operations to solve. So we're going to set this up in 2 ways. Okay, so over here we'll have distributive property, and over here we'll have order of ops. Okay, now how many books did they sell? So Johnny sold 12 and MJ sold 9. Okay, and they sold them for how much? $5 each. Now using the distributive property, you would need to multiply this 5 through to what's inside your parentheses. So now we have 5 times 12 plus 5 times 9. And then we would solve accordingly. Using order of operations, we would complete what's inside the parentheses first and then solve. So 12 plus 9 is 21. And then we have our 5 on the outside. Regardless of what method is used, as long as we follow the rules for distributive property and for order of operations, our answer should still come out to be the same. So now let's go ahead and solve the distributive property. So 5 times 12 is 60. 5 times 9 is 45. 60 plus 45 is equal to 105. Okay, so in total, they sold $105. Okay, and I'm just going to use my $sign to represent that. Now let's take a look at the order of operations. So now I have 12 plus 9 is 21, 5 times 21. 5 times 1 is 5, 5 times 2 is 10. So here, it also shows that they sold $105. 2 different approaches, exact same answer, so we know we did our work correctly. Deasia charges $3 for each cupcake at a bake sale. She sold 4 cupcakes on Monday, 6 cupcakes on Tuesday, and 2 cupcakes on Wednesday, and then 2 more on Thursday, and then 10 on Friday. How much money did she earn? Okay, so here let's talk about the number of cupcakes. So we know that our expression is going to be cost times number of cupcakes. Okay, now let's see, what is our cost? Her cost is $3. And we're going to multiply that by the total number of cupcakes. So she sold 4 one day, 6 another, 2 another, 2 another, and then 10. So let's just make sure that we accounted. So 4 for Monday, 6 for Tuesday, 2 for Wednesday, 2 for Thursday, and 10 for Friday. Okay. Now using order of operations, we're going to do what? We're going to complete our parentheses first, and then we'll multiply by what's on the outside. 4 plus 6 is 10. 10 plus 2 is 12. 12 plus 2 is 14. And then 14 plus 10 is 24. So over those 5 days, she sold a total of 24 cupcakes, and we know the price per cupcake is $3. So let's go ahead and multiply. So 24 times 3. 3 times 4 is 12. 3 times 2 is 6, and 1 is 7. So in total, she earned $72. Okay. Matt has $450 in his wallet. He spends $210 on food at the grocery store. He later found $50 on the sidewalk. How much money does Matt now have in his wallet? Okay, so he started off with $450. The action of spending money is going to be subtraction, right? So he's putting this money out, so that's minus 210. And then later on he found, so the action of finding is like getting money, so that's a plus 50. So here we're going to subtract, add, and all that good stuff to figure out how much money he does have in his wallet. Now we know that based on GEMDAS, addition and subtraction are on the same level from left to right. So I want to subtract the 210 from the 450 first, and then I'm going to add that $50. So let's go ahead and set up on the side. So 450 minus 210, 0 minus 0 is 0, 5 minus 1 is 4, 4 minus 2 is 2. So this is 240 plus 50. So I'm going to add the 50 here. 0 plus 0 is 0, 4 plus 5 is 9, and I bring down the 2. So after all of those transactions of spending $210 and then finding $50, Matt will have $290 in his wallet. Okay. If you find that you might need to see another example, go back, pause the video, watch, take some notes, try the problem on your own, and then take a look at the answer. Okay. Thank you for watching and have a wonderful day.